In this presentation, we're going to do a quick review of operations with sign numbers and also fractions. We're going to start with addition and subtraction, and I'm going to combine these as two because ultimately it's the same basic operation. In order to add numbers with same signs, we want to add disregarding the signs and then keep the sign. To add numbers with different signs, we want to subtract, disregarding the signs, and keep the sign of the larger number. When subtracting sign numbers, you don't want to think of the minus as an operation. You want to think of it as the sign of the number. And then you want to use the rules for adding sign numbers in terms of are they same signs or different signs. Now, the one thing to keep in mind is when you are subtracting a negative, you want to change the minus a negative to a plus sign. Then again, combine the numbers using the rules for adding sign numbers. One of the ways that you can kind of think about this is think in terms of your bank account. In terms of, do you have money? Are you overdrawn? Are you depositing money? Are you withdrawing money? And what would be your resulting balance? For some reason, as soon as we put money in front of it, everybody knows exactly how much they have in their bank account. All right, so let's go ahead and look at some examples and see what we can do. All right, if we go ahead and look at the following examples, we have 3 plus negative 8. And so when we look at this, we want to think we're seeing this is an addition problem. And so we want to think, do we have same signs or different signs? Here we have a positive number combined with a negative number. So we do have different signs. And in order to combine numbers with different signs, we are going to subtract the numbers. And when we do our subtraction, remember we always do larger minus smaller. So we want to do 8 minus 3, which is 5. And then to determine the sign of our answer, we want to keep the sign of the larger number. And so this is equal to negative 5. If we come over to example B, we have negative 7 plus 12. Here we are adding sign numbers. And so same rule apply. We have different signs. We want to subtract. 12 minus 7 is 5. And then because our larger number is positive, our answer is positive. For example C, we have negative 5 plus 1. And here what we want to do is we are adding, so we do want to think of same signs or different signs. We have different signs here, so we want to subtract. We're going to do 5 minus 1 is 4. And then because our larger number is negative, our answer is negative. And so our final answer is going to be negative 4. Example D, we have negative 2 plus negative 10. Here these numbers have same signs, and because they have same signs, we are going to add 2 plus 10 to get 12, and we keep the sign. Final answer is negative 12. All right, so these are all examples of adding sign numbers, and so now let's go down and look at some subtraction problems and talk about how are we going to look at this. Example E, we have 8 minus 12. And so again, remember, we do not want to think of this in terms of a subtraction problem. We don't want to think of it as an operation. We want to think of this as the sign of the number. And what we are essentially doing here is we are combining 8 and negative 12. Now, whether you choose to write it out like this or not is up to you, but this is ultimately what we all should be thinking. Because we have different signs, we have a positive 8 and we have a negative 12. Different signs we do want to subtract. And if we subtract these, we get 12 minus 8 is 4. And my larger number is negative, so it's going to be negative 4. Example F. We have negative 4 minus 7. And again, we want to treat these as the signs. We want to think of this as negative 4 combined with negative 7. Because we have same signs, we said negative 4 and negative 7, we are going to add and keep the sign. And so our final answer is going to be negative 11. All right, example G and H, these are the ones that we do want to change it to an addition problem. When we see negative 8 minus negative 11, we want to rewrite minus negative 11 as a plus. There are several different ways to think about this. If you are a visual learner, if you see two negatives that are right next to each other, pretend that you can pick them up off the page and make a plus sign out of them. In English, double negatives, English majors hate double negatives. And if you use a double negative in an English class, you're probably going to get marked up quite a bit. But just think about the statement, I did not misunderstand you. And that is just a very sarcastic way of saying, I did understand you. And the negatives cancel out. They do the same thing in math. And so here, minus a negative becomes a plus. We get negative 8 plus 11. And now we're back to our rules about adding sign numbers. We have different signs. We are going to subtract. My larger number is positive. And so my final answer is positive 3. For example H, we have the same thing. The first thing I want to do is, if I see any minus and negatives, I want to change it to a plus sign. And so this is going to become negative 12 plus 7. We have different signs, and so we are going to subtract, keep the sign of the larger number, and we get negative 5. All right, so that is adding and subtracting. The next thing we want to look at is multiplication and division. And so multiplication and division is easier than adding and subtracting because we don't have to change our operation. Multiplication is always multiplication. Division is always division. We don't have to keep track of which number is bigger, which number is smaller. All that we need to know is how many negatives in the problem. And so, for multiplication and division, we have to multiply or divide signed numbers. You multiply or divide the numbers disregarding signs. If there is an even number of negatives, the answer is positive. If there is an odd number of negatives, the answer is negative. We also have a couple rules involving 0. If you have 0 divided by a number, it is equal to 0. On the other hand, a number divided by 0 is, we call it undefined. You are never allowed to divide by 0. I know that when I was a student at NMSU, there was a classroom in the science hall that had two signs up on the wall. The first one said, please do not smoke, which I'm pretty sure we can all agree on. It's not allowed indoors. And the other one said, please do not divide by 0. And so I always remember that classroom. All right, so let's go ahead and see what we get here on a couple problems. Okay, so example A, we have 6 times negative 8. If we multiply, we're going to multiply 6 times 8. That is equal to 48. We have 1 negative in our entire problem, which means that my answer will be negative. And so 6 times negative 8 is negative 48. If we come to example B, we start by multiplying the numbers. We get 3 times 6 is 18. We look for negatives. I have 1 negative, which means that my final answer is negative 18. All right, for example C, again we are going to start by multiplying our numbers. We get 4 times 11 is 44, and here we have 2 negatives. And just like when we talked about subtracting a negative, if you have a negative times a negative, you can go ahead and cancel those 2 negatives out. Now note, this only works with multiplication or subtracting a negative. And subtracting a negative, you can also think of it as multiplying -1 times a negative number. We can cross these out, and we cross them out in pairs. Because I don't have any negatives left, that means my final answer is positive. All right, let's come to example D. Just to show you kind of what happens when we add more numbers into the problem. So here, I'm going to just start by multiplying my numbers. And again, I'm going to do this disregarding signs. So if I multiply 3 times 2, I get 6. And you can multiply this however you want, but I can also multiply 4 times 5 and get 20. And if we multiply 6 times 20, we get 120. Now you can either work with the negatives as you're multiplying the numbers, or you can wait until the very end, or technically you can do this at the very beginning. Remember, we said that if we can pair them up, they cancel out. So for instance here, these 2 cancel out. We can also cancel out these 2. And I don't have any negatives left in my problem, which means that my final answer is 120. Now, one thing to note is that we'll see later on when we get into exponents is if you have an even number of negatives, your answer will be positive. And if you have an odd number of negatives, your answer will be negative. That's kind of an extension of the rules listed above. All right, let's look at some division problems now. For example E, we have 40 divided by -8. We divide 40 by 8, we get 5. And because we do have 1 negative in the problem, my final answer is going to be -5. For example F, we have -36/3, or divided by 3. If we divide, 36 divided by 3 is 12. We have 1 negative in our problem, and so my final answer will be -12. Example G, -72 divided by -8. we're going to divide our numbers first. If we divide 72 by 8, we get 9. And just like with multiplication, with division, we can go ahead and cancel out our two negatives, and we get that this is equal to positive 9. And finally, for example H, we have a problem involving 0, and so the question is this equal to 0 or is this undefined? And so this one is undefined. You are not allowed to have the 0 on the bottom. And if you want, you can think in terms of fractions. Have you ever seen a fraction where the denominator is 0? We don't do it. We can do 1/2, 1/4. Technically, you can do 4/1, but you can never have a bottom of 0. When we talk about division, what we are basically doing is the opposite of multiplication. And so, for instance, if we go back to example G, when you look at negative 72 divided by negative 8, what this translates to is negative 8 times what is equal to negative 72. And to do this, we need 9. When we look at H, what this means is 0 times what is equal to negative 24. And this cannot be done. 0 times anything is 0. It is never equal to anything else. And so that is why we call this one undefined. If you are not comfortable with these rules involving 0, then I do recommend using a calculator. One of them will give you an answer of 0, and the other one will give you an error message. And the error message is telling you that the calculator cannot compute it because it cannot be done. All right, so hopefully that makes a little bit of sense. Okay, how are we going to apply this moving forward? As we move forward in math class, we will be working with sign numbers in everything that we do. We will see it when we talk about evaluating and simplifying expressions. We will see negatives when we talk about rules of exponents. We will be working with these numbers when we talk about solving and graphing different types of equations, solving inequalities. And so no matter what, you are going to have to work with sign numbers as we move forward. All right, that takes care of our basic operations with integers or just regular numbers. And so now we want to go ahead and apply this to our fractions. So, operations with fractions. We're going to start with multiplying. So multiplying, there is only two basic steps that you need in order to multiply fractions. The first thing that we want to do is cancel common factors that appear in a numerator and a denominator, and then multiply the results straight across. Now technically, you can do this in either order. You can multiply and then simplify. But the problem with multiplying first is you may end up with some numbers that are really large and really hard to work with. And so it's always recommended that you cancel first so that you're working with numbers that won't require you to have to reach over and grab a calculator. The last thing you want to do is check that the fraction is in lowest terms. And then also remember your rules regarding signs. All right, so let's go ahead and look at a couple of examples. We want to evaluate these and we want to write in lowest terms. So for example A, we have 8 over 9 times 15 over 28. So the first thing that I'm going to do is I'm going to go ahead and cancel common factors. has to be with a top and a bottom. So, for instance, 8 and 28 are both divisible by 2, but we want the largest number that goes into 8 and 28, and that is 4. If we divide 8 by 4, we get 2. And if we divide 28 by 4, we get 7. All right, let's see what else we can do. 9 and 15 are both divisible by 3. And so if we divide by 3, 9 divided by 3 is 3, and 15 divided by 3 is 5. We can now go ahead and multiply these new numbers straight across. If we multiply 2 times 5, we get 10. And if we multiply 3 times 7, we get 21. And that is our final answer. 10 over 21. 10 and 21 do not have any other common factors, and so this is in lowest terms. All right, let's come to example B. Example B, we have negative 3 over 5 times negative 20 over 27. So we are going to start by canceling common factors. And so the first thing I notice is that 3 and 27 are divisible by 3. If we divide by 3, we get 3 divided by 3 is 1. 27 divided by 3 is 9. We can also, so is there anything else that we can cancel? And there is. 20 and 5 are both divisible by 5. And so if we divide 5 by 5, we get 1. And if we divide 20 by 5, we get 4. Now we do want to remember, or it doesn't matter what order we do this in, but if we go ahead and multiply straight across, we get 1 times 4 is 4, and 1 times 9 is 9. And we do want to make sure that we are careful. If you need to, highlight your negatives when working, especially with fractions, so that they don't disappear. But here, because we do have 2 negatives, they cancel out. And so my final answer is going to be positive 4 over 9. All right, last one, we have example C. We have 4 over 11 times negative 33. Now the first thing that we want to do is, if you notice it said cancel common factors with tops and bottoms, and so before we can multiply fractions, the first thing that we need is everything has to have a top and a bottom. So 4 over 11 meets the criteria. Negative 33 does not. So how do we write this as a fraction? We are going to go ahead and just write it over 1. From here, we can go ahead and cancel common factors. 33 and 11 are both divisible by 11. And so if we divide 11 by 11, we get 1. And if we divide 33 by 11, we get 3. Nothing else cancels, so we can multiply straight across. We get 12 over 1, or if you want, remember that if it's over 1, it's just the number itself, so we get 12. We do also have 1 negative in our problem, and so we do need that in our final answer. And so our final answer is negative 12. Now, one of the things, if you notice, you might be asking me, well, why did you put it on the top instead of in the front? Just so you know, with fractions, it does not matter where you put the negative. Me personally, I do prefer writing the negative in the numerator, as it is less likely to get swallowed up by the fraction bar. Ultimately, it's up to you. The important thing is that you put it somewhere where you can see it. All right, let's go on to dividing fractions. This is the next easiest operation. And so to divide fractions, what we want to do is we actually want to change the operation to multiplication. And we want to take the reciprocal of the second fraction. If you don't remember, reciprocal just means flip it. From there, it is now a multiplication problem, and so we use the rules for multiplying fractions. We want to cancel common factors, and we want to multiply straight across. If you don't like all the fancy math jargon, I had a student who taught me one semester that he had an instructor who told him the way to remember division is copy, dot, flip. Just 3 little words, and it tells you exactly what to do. So let's go ahead and see how this works. If we look at example A, we have 12 over 35 divided by 20 over 21. Now, one of the important things to remember is make sure that you do your copy dot flip or your change it to multiplication before you start canceling anything. If we go ahead and copy dot flip, this is how it works. We copy, we dot, and we flip. It's now a multiplication problem, so we want to cancel common factors. And so let's see here, 35 and 21 are both divisible by 7. And if we divide by 7, we get 21 divided by 7 is 3. 35 divided by 7 is 5. We can also divide 12 and 20 by 4. And if we divide 12 by 4, we get 3. If we divide 20 by 4, we get 5. Now, one thing to note, we do still have some 3's here and we have some 5's here. They cannot be canceled because remember that when you cancel, it has to be a top with a bottom. We don't have any more tops and bottoms that can cancel, and so from here we multiply straight across. We get 3 times 3 is 9 over 5 times 5 is 25. All right, let's bring in our signed fractions. For example B, we have negative 5 over 6 divided by negative 4 over 9. We want to copy dot flip. And if we do that, we get negative 5 over 6 dot flip the second fraction. We get negative 9 over 4. Now again, as I mentioned previously, I always like putting my negatives in the top so that they are on the same level. It ultimately does not matter where you put them. We'll see this when we get to our final answer. All right, so now let's see here. Can we cancel anything? And we can. We can divide 6 and 9 by 3. And if we do that, 6 divided by 3 is 2. 9 divided by 3 is 3. And that's it. 5 and 4 don't have any common factors, and nothing else here in terms of top and bottom have common factors. And so we can go ahead and multiply straight across. 5 times 3 is 15. 2 times 4 is 8. And because we do have two negatives, they cancel out, and my final answer is positive 15 over 8. If you want, you may write it as a mixed number, but that is really not going to be much of a requirement anymore in your math classes. You may leave it as an improper fraction, and we actually do prefer that it be left as an improper fraction, except for when we're maybe doing application problems, and I don't think we're going to see any of those. All right, last example for division. We have 3/4 divided by negative 12. And so for this one, what we want to do is we are going to start, before we do our copy.flip, the first thing that we need to do is we do need to turn negative 12 into a fraction. And so I'm going to rewrite this as negative 12 over 1. We can now go ahead and copy.flip, and we get 3 over 4, copy, dot, and we can flip. You can put the negative on the bottom, but again, I always like having my negatives on the top. From here, we want to know, can we cancel anything? And we can. 3 and 12 are both divisible by 3. And if we divide by 3, we get 1. 12 divided by 3 is 4. And we want to multiply straight across. If we multiply straight across, we get 1 times 1 is 1 over 4 times 4 is 16. Make sure that you keep the numerators in the numerators and the denominators in the denominators. You cannot rewrite this as 16. If you have 1 out of 16 pieces of candy, that is not the same thing as saying you had 16 pieces of candy. The other thing that we have is we do want to remember our signs. We have one negative in this problem, and so my final answer will be negative 1 over 16. All right, that takes care of our division. All right, and finally, the last thing that we want to look at is adding and subtracting fractions. So adding and subtracting fractions for most students is the one that kind of screws everybody up. And so the thing to remember that when you add and subtract fractions, this is the one where we have to have same denominators. And so we want to start by finding and rewriting all of the fractions with the LCD, which stands for least common denominator. As soon as the fractions have the same denominator, you can combine the numerators and you keep the denominator. Finally, you want to simplify the result by dividing by the GCF, or the greatest common factor. All right, so let's go ahead and look at some examples of this and just get a little bit of review. All right, example A, we have 1/3 plus 1/6. And so the first thing that we need is a least common denominator. And just to remember, this is something that we are going to be multiplying by, or multiplying to. So for instance, some people want to say 3, but the thing is that we cannot multiply 6 by something in order to get to 3. So we are looking for a number that is divisible by 3 and 6, and that is going to be 6. You can also use the product of the denominators. Here, if you multiply 3 times 6, you get 18, and that's perfectly fine. You can use that. The only thing is if you go with something that's not the least common denominator, you will have to simplify your final answer. Whereas if you go with the least common denominator, then you only might have to simplify. All right, so we have our LCD of 6. And so what we want to do is I want to know, okay, what do we need to multiply 3 by in order to get to 6? And the answer is 2. And so we want to multiply the bottom by 2, but remember that you can't just do this one way or to one number. you have to balance it. And so we want to multiply the bottom by 2. We also want to multiply the top by 2. Whatever we do to the bottom, we have to do to the top. So here, if we multiply, we get 2 over 6 plus 1 over 6. Now that we have same denominators, we can go ahead and add the tops. 2 plus 1 is 3, and we keep the bottom. When you read this, you can think of the denominator kind of like a unit. If you have 2 feet plus 1 feet, you end up with 3 feet. If you have 2 sixths plus 1 sixth, that's equal to 3 sixths, or 3 over 6. From here, we want to try to simplify the fraction. Top and bottom are divisible by 3. And so just like when we multiply top and bottom by the same number, same rules apply with division. If we go ahead and divide top and bottom by 3, we get 1/2, and that is our final answer. All right, let's come over to example B, and we're going to get into some sign numbers. So example B, we have negative 4 over 5 plus 1 over 2. And so the first thing we need is an LCD. I want to know what is a number that is divisible by 5 and 2. And for this one, it is 10. So for the first fraction, how do we get from 5 to 10? We want to multiply by 2. And again, whatever we do to the bottom, we do to the top. This becomes 8 over 10. And I recommend that you use a highlighter on this because you want to make sure that you don't forget the negatives. This is going to stay negative 8 over 10, and again, I'm just going to put it up in the top to kind of make sure that it's clear that it doesn't get swallowed up by the division bar. All right, second fraction. How do we get from 2 to 10? Here we want to multiply by 5. And again, whatever we do to the bottom, we do to the top, and we get 5 over 10. We want to combine this, and so when we look at these fractions, I want to know, do we have same signs or different signs? The first fraction is negative, and the second fraction is positive, so these are different signs. And remember, with different signs, we want to subtract, keep the sign of the larger number. It'll be negative 3, and we keep the denominator. This fraction cannot be simplified, and so this is our final answer. All right, last one, we have negative 2 over 9 plus 5 over 12. And so we want to know, what is the LCD? For 9 and 12, take a few minutes and think about what you think it might be. And if you said 36, you would be correct. If you are not sure, you are allowed calculators, okay? 12 is not divisible by 9. If we do 12 times 2, we get 24, and that's not divisible by 9. If we do 12 times 3, we get 36, and that is divisible by 9, and so that is my least common denominator. All right, so the first fraction, how do we get from 9 to 36? We want to multiply by 4. And again, whatever we do to the bottom, we do to the top. This becomes 8 over 36, and we do have that negative right there, and so we do need to make this negative 8 over 36. Sorry, that's supposed to be a 36. All right, second fraction. To get from 12 to 36, we want to multiply by 3. And again, whatever we do to the bottom, we do to the top. And this is going to become 15 over 36. We want to combine our fractions, and so do we have same signs or different signs? Here we have a -8 and a +15. So we do have different signs, which means that we want to subtract 8 from 15. We want to keep the sign of the larger number, so this is going to be positive. And we keep the denominator, and so we get 7 over 36. All right, now let's go ahead and look at some subtraction problems and see what we can do. We'll start off basic. We have 7 over 10 minus 1 over 5. And so my LCD, again, remember this is something we have to multiply to, is going to be 10. 5 is the greatest common factor. 10 is the least common denominator. And for some reason, least is bigger and greatest is smaller. It's very backwards. All right, first fraction, we already have a denominator of 10, and so we are going to keep this the same. The second fraction, to get from 5 to 10, we want to multiply by 2. And whatever we do to the bottom, we're going to do to the top. If we multiply this, we get 2 over 10. And now if we subtract, we get 7 minus 2 is 5 over 10. And you can still use the rules of sign numbers. Here we have a positive fraction and a negative fraction we want to subtract. Our larger number is positive, and so our answer is going to be positive. We keep the denominator, and then we want to simplify. 5 and 10 are both divisible by 5. And if we divide by 5, we get 1 over 2. All right, let's look at our signed fractions. All right, example E, we have -1 over 6 minus 2 over 15. We want to do an LCD. And so take a minute and think about what the LCD might be. And here, this is one of the more difficult LCD problems, but again, if you're not sure, let's work with the larger number. 15 times 1 is 15. And is 15 divisible by 6? And the answer is no. If we multiply 15 times 2, we get 30. And is 30 divisible by 6? And the answer is yes. So 30 is our LCD. All right, first fraction. What do we need to multiply by in order to get from 6 to 30? We want to multiply by 5. We get 5 over 30, and we do have that negative there, and so we do need to make sure that we keep the fraction negative. The second one, we want to multiply 15 times 2 to get to 30. Again, whatever we do to the bottom, we do to the top. And so this becomes minus 4 over 30. And so now do we have same signs or different signs? Remember in the earlier slide, remember that we said we don't want to think of this minus as an operation. We want to think of it as the sign. And so here we are trying to combine -5 over 30 and -4 over 30, which means we have same signs. Because they are same, we are going to add, we are going to keep the sign, and we're going to keep the denominator. From here, we want to divide by the greatest common factor. 9 and 30 are both divisible by 3. And so our final answer is negative 3 over 10. All right, last example. We have negative 8 minus negative 2 over 7. The first thing that I want to do is, just like when we talked about integers, I want to change any of my minus and negatives to a plus sign. So I am going to rewrite this as negative 8 over 9. I'm going to change my minus and negative to a plus, and I'm going to rewrite this as 2 over 7. All right, LCD. LCD for 9 and 7. If you're not sure, you can go ahead and multiply them together. 9 times 7 is 63. And it is, in fact, the LCD, not just a common denominator, it is the least common denominator. All right, from here, we want to multiply 9 times 7 to get to 63. Whatever we do to the bottom, we do to the top. We get 56 over 63. We do have a negative, and so we're going to keep the negative, plus. To get from 7 to 63, we want to multiply by 9. And if we multiply by 9, we get 18 over 63. All right, from here we want to go ahead and subtract. And right now I will be honest that it's kind of late. You may use a calculator for this, but I don't have mine. And so I'm going to go ahead and make sure I do this correctly by subtracting longhand. And we get 38. And it is going to be negative 38. We have different signs, so we do want to subtract. And we want to keep the sign of the larger number. And so this is equal to negative 38 over 63. (38) and 63 do not have any common factors, and so this fraction is in lowest terms. All right, so now, moving forward, how are we going to apply this? In this class and fractions, I know that everybody hates fractions. I refer to fractions as the first F word in math, and it's something that everybody struggles with. Now, I will tell you that for these problems in the homework and on the quizzes and on the test, I am expecting you to do these by hand. And the reason is because as we get further into this class, we're going to encounter fractions when we talk about solving equations, when we talk about finding equations of finding linear equations in two variables and slope. We will also expand these concepts when we talk about simplifying rational expressions and solving rational equations. And that is really where you need to know these rules, because we're going to introduce variables into the mix. And if you don't know the rules when working with numbers, it makes it even more challenging. We will also revisit fractions when we talk about rules of exponents and radical expressions, or roots. All right, so that is our review of numbers. And hopefully this has helped you out just a little bit. These are things that you should be working on over the course of the semester and improving on. And if you struggle with it, don't worry, it just takes practice.